Hello, ladies and gentlemen. This is my second time doing this video because I kind of didn't turn the mic on and recorded the video. So now I got to do it over because there was no sound. So I decided to, before I do it, make myself some breakfast, and I'm gonna try to finish this before my breakfast get cold. So let us begin. You guys know how to solve equations. Since you know how to solve equations, there's nothing to it. All an equation is just a math sentence with an equal sign. So with that being a math sentence with an equal sign, like say here, then both sides have to be equal at all times. So in other words, if I subtract 12 on one side, hold on, if I subtract 12 on one side, to keep the balance, I have to subtract 12 on the other side as well. So that crosses out. You have 7x equals 35. Again, y'all know how to solve equations. Now, what I will say is that the value that makes an equation true is called a solution. And when you guys get higher up, it's called a root. When you get to algebra 2, pre-calc, and stuff like that, they'll use that even more. Now, things can get a little bit trickier. So say these two problems right here. I'm going to solve these problems. I think you should try and solve these two problems too, and then compare, and I'll explain a little bit when I get back. So go ahead, pause the video and solve these problems and see what you get. Okay, I'll unpause right here just to show you that I distributed the 3 over 2 to both those terms. I get 3 over 2z minus 15 over 2 equals negative 6, right? So then if I add 15 over 2 to both sides, I get 3 over 2z is equal to 3 over 2. And all that means is that z is equal to 1. Now you could go about it that way, or there's another way that you can go about this as well. If I get it all by itself over here again, with this problem, really I could have got rid of the fraction. I don't like fractions in the equation, so I could have just got rid of my fraction here. Multiply that by 2 over 3, and then multiply this by 2 over 3. You don't have to multiply everything by 2 over 3 because it's in parentheses and it's being multiplied. If I do that, those fractions cancel out. I'm left with the z minus 5 equals, what's the, let's see, that cancels and that cancels, and this becomes what, 2. So z minus 5 equals negative 4. Add 5 to both sides, just like how we had over there. Z is equal to 1. So it's your choice which way you want to go about it. Here I don't like fractions, so I got rid of the fractions when I needed to. Let's discuss some different solutions we can get when we solve these equations. If you solve this one right here, watch the solution we get when we actually do it. All I did there was just distribute the 3 into this parentheses and distribute the 6 into this parentheses, right? So from here, combining like terms, I'll get that 6s minus 9 equals 6s minus 4. Now remember how I said in an equation that both sides have to be equal to each other. There's no way that these two sides can be equal to each other because 6s minus 9 can never equal 6s minus 4. To give you a little bit more perspective, what if I subtract 6s on both sides? Subtracting 6s on both sides cancel that out. I'm left with negative 9 equals negative 4. Now that is a false statement. So since that's a false statement, we can't have a solution. So no solution for that problem. Similarly, if we talk about the other problem that we have, if I try to solve that, again, all I did there was distribute the 3 and distribute the 6. So I got 6s minus 9 equals 6s plus 6 minus 15. So combining like terms, 6s minus 9 equals 6s minus 9. Now notice here we have the same thing. It's possible that those, matter of fact, not only is it possible those two things be true on the opposite sides of the equal sign, but if we go a little bit further, don't we get negative 9 equals negative 9? Now looking at that, that is what a true statement. So since that's a true statement, that means every value of s will work. So we say all, not all real, all real. Why is this not working the way I need it to? All real numbers. So those are different solutions you get with these equations. Now, how about this? What I want you to do, pause the video and find my mistake. Pause the video and let's do this one first. So this one right here, I want you to find my mistake and come back and we'll discuss it. Now remember how I said that I like to multiply both sides by something to get rid of that fraction? It's exactly what I did. If I multiply both sides by 2, right, this 1/2 cancels out with that 2. I'm left with 2x minus 10 on one side. Over here, 4 times 2, this should be 8. If that's 8 and then I add 10, this should be 18. So then that means if I divide by 2, this should be 9. It's more important to recognize and analyze an actual problem to find out what could have been done differently and stuff like that. So why don't you guys try this problem now? So pause the video, see if you see the mistake, and we'll come back and talk about it. Now some of you might think there's no mistake here because I did everything that I needed to do, but really the mistake is in the solution. With the mistake being in the solution, the reason why is because remember how I said that this right here is a true statement. So if that's a true statement, the solution is not y equals 0. The solution is all real numbers. So we'll do more of those as time goes on. We can actually discuss solving equations that have fractions in it. Now, solving this equation, again, there's ways that people like to go about it. I'll show you the way that most people like to go about it, and I'll show you the way I go about it. No, not that one, this one. With this problem, usually what people like to do is subtract 4 on both sides. They'll get 1/2 x equals 3. Then they'll multiply both sides by 2 and be left with x equals 6. That's how most people go about it. It's fair. When I have fractions, I like to get rid of the fractions from the very beginning. So I'm just going to multiply by the least common denominator. Let me write that. Now, the least common denominator is there's only one denominator. So you know the least common denominator in this case. Oh, hold up, wait a minute. Let me go back. The least common denominator in this case is equal to 2. So if it's equal to 2, then I'm multiplying this whole thing. Let me get that out of the way so we can multiply the whole thing. We can multiply the entire thing by 2. That means that I multiply 2 by 1/2 x. If I multiply 2 by 1/2 x, the 1/2 and the 2 cancel. Left with just x. The 2 being multiplied by the 4, it's 8. 2 being multiplied by 7 equals 14. Subtract x equals 6. I just like getting rid of the fractions. And it's more valuable when you have more than one fraction. Say you have 2 fractions here in this problem. The least common denominator is equal to 6, right? Because denominator is 3, 2. So if that's the case, let me multiply this entire problem by 6. If I multiply by 6, I cross out with this 3. If I multiply 6 by 2/3, the 3 crosses out with the 6, and I'm left with 2 to multiply with there. I multiply the 6 by 1/2. The 2 and the 6 cross out. I'm left with the 3 to multiply by. And I also am multiplying the 6 by this 11 over here. So you end up with 4x. 4x plus 3 equals 66. That means that 4x equals 63. X equals 63 over 4. Now, you don't have to go further. You can just leave it as an improper fraction. You don't need to make it a decimal or anything if you want to. I'm not mad at that. So we can leave it just like that. Alright, how about this? With this problem right here, remember you're multiplying by the least common denominator. The least common denominator in this entire case is 12. Because all the denominators, so you're multiplying every last one of them by 12. So why don't you take some time, do this problem, and then come back and see if in fact we have the same answer. Go ahead and do this problem. We'll pause and do the problem. Now, I multiply the entire thing by 12. You should have got 16z plus 18z equals 51. Combine those, 34z equals 51. Z equals 51 over 34. Please reduce your fractions. If I've reduced my fraction, that should be 3 over 2. We'll do more of those as we get into class, but that's with fractions. Decimals, not so much different. Ultimately, I want to get rid of the decimals as well. If I want to get rid of my decimals, then there's an easy way to go about it. If I want to get rid of my decimals, first thing is, why don't I just, I don't know where the bar is, okay. To get rid of my decimals, you're multiplying by, let's say, powers of 10. Wait, that's not how you spell powers. Let's see, powers of 10. The reason why is because you want to jump the decimal point. That'll get rid of my decimals. So in order to jump, I only want to jump in one space. That's what it looks like to get rid of my decimals. So in order to jump one space, all we're multiplying by is 10. But since we're doing it to both sides, the equation remains balanced. I don't know what just happened here. Let me fix it. Now, if I multiply that entire thing across, I'm just jumping the decimal place. So if I multiply this 0.1 by 10, jumps to decimal place. 2.5 by 10 jumps to decimal place. Also have to multiply this 10 by 10, jumps to decimal place. So what that means is that this is going to turn into x plus 25 equals 100. So in other words, x equals 75. So we have that, right? The next one we have equations with decimals. Our equations with that, well, we have this one, the equation where you have two decimal places. If you have two decimal places, now we're not going to multiply by 1 because remember we got to jump it twice. And to jump my decimal place twice, I got to multiply by 100. That's going to jump this decimal place twice too. So I'll end up with 220x plus 196 equals 306. Let me rewrite that. 306. So because of that, it's an easier equation to solve, right? Subtract 196 on both sides, you get 220x equals 110. X equals 110 over 220, which is just 1/2. So they get easier when we they get easier when we multiply by some power of 10 to move our decimal point. Say over here, negative 14.369. Now what you guys have to understand is when we take this one, you have to jump 3 decimal places. So that means you are multiplying by 1000. So let me actually, I need some room for the problem, so let me actually go over here. Multiply this by 1000. And if you multiply that by 1000, we'll actually see what happens. This decimal point is going to jump again 3 spaces, right? So you're going to have negative 14,369. What a lot of people forget to do is multiply by something that looks like it doesn't have a decimal place. You do have to multiply by that as well, so that's going to be 1000n, right? And then you multiply by the 1.7, that jumps 3 spaces, so that's minus 1700, and then plus 3223n. Again, looks like an easier math problem to do, right? So since it's an easier math problem, we can solve. When we go through the motions, we end up with n equals -3. So it's not that bad once we get rid of the decimals. We get rid of anything that we try to get rid of these because they throw us off, right? Equations with variables on both sides. Again, you guys know how to do these, so how about this? Why don't you guys pause the video again, do these 3 problems based on all the things that we've talked about, and do those 3 problems, see what you get, come back and compare your answers with mine. So go ahead and pause the video. Wait, let me come back right here real quick. Here I'm not going to multiply both sides by 4 because it's going to be a little bit more complex. It's your choice if you want to. Just if you're going to multiply both sides by 4, just understand that's in parentheses, so you have to distribute the 4. But I'm not necessarily going to do that here. Instead, I'm going to distribute the 1/4 to make the equation. It's all about making the equation look a little simpler. So I'm going to distribute the 1/4. So it's 9x minus 5 equals 4x plus, what's that, 15? All right, let's bring that over here. 5x, x equals 4. So hopefully you guys got the same thing with that. Let me do the other one. Uh, I definitely didn't multiply both sides by 3 over 2. Instead, I just distributed the 2/3. So I got y equals 4 on that. So we have those problems. I hope that you ended up with something similar, something we can discuss in class. The next thing we'll discuss in class will come here. I'm not going to do these things until we're all together, but let's actually deal with that when we come back. So that's the end of this video.